Sorry. Okay. So today we're doing solving equation notes. Okay. Okay. Try it yourself. So solve for n. 3n minus 5 equals 13. So see if you guys can get this. Right, so the correct answer is 6. Nice. Should be pretty easy. First you isolate the variables. So you move 5 to the other side so you can only have 3n by itself. And then that becomes 18. You divide that by 3 and you get n equals 6. Okay. Alright, try this one. Negative 6n plus 4 equals negative 8. Right, nice job. The answer is 2. Move 4 to the other side and then divide by negative 6. And then when you move 4 to the other side, 4 has to become negative. This is negative 12 divided by negative 6 is 2. Okay. So try this one. 5n plus 3 equals 7n minus 5. Right, nice job, guys. The answer is 4. I'll explain it real quick. So it's just 5n plus 3 equals 7n minus 5. So the first step is to isolate the variables. So we move the variables all to one side. So let's just move it all to the left-hand side. So it's just 5n minus 7n. And at the same time, we move the constants to one side. So now it's minus 5 minus 3 because they switch signs. So you get negative 2n equals negative 8 and n equals 4. You can do it other ways as well, but this way works too. Okay. So let's try a problem from MathCount's handbooks. Solve for n. Right, nice job, everybody. It's 14 over 6 or 7 over 3 or any variation of that. I think MathCounts likes it if people simplify, so I think 7 over 3 would have been better, but since it didn't really ask, 14 over 6 also works. So just for this one, it's like using, I think it was rule number 1, to get rid of denominators, you just multiply both sides by whatever the denominator is. So just multiply both sides by 4. So you just get n plus 1 equals 20 over 6. And then n equals 14 over 6. Because we move 1 to that side. Okay. Continuing onwards. Okay, let's try to solve this problem. Also from Math Counts handbooks. Alright, I think everybody caught themselves in the end and got it right in the end, so nice job. The answer was -5, but I will explain it quickly because there was a little bit of confusion. Okay, so I would distribute first instead of multiplying by 2 because we see the inside is all even, so distributing would probably be better. So you get 2n, oops. You get 2n minus 4 equals 3n plus 1. So let's just move everything to left-hand side. So you get -n, and then move the constant to the right-hand side, equals 5. 4 plus 1, and then n equals -5. So you have to be careful with signs. It gets a little tricky sometimes. Okay. I'll skip this one. Okay. So the next one is solving literal equations. So basically, literal equations are just like equations, except for the equations we were talking about before, except for instead of having just one variable, x or y, we now have two variables, and the answer won't be a fixed value the whole time. So this is like going kind of into more depth. So like, for example, x is the variable in the equation ax equals b. So now we have more than one variable. So if we like solve for x equals b over a, we could write that. So so since this is on the denominator, it can't equal 0, but if it does equal 0, then, so that's case 3. No, that's actually case 2. If when it does equal 0, if they both equal 0, it has infinite many solutions, because basically you have 0 times x equals 0, and then x can be anything. So, and then when a doesn't equal 0, x equals b over a, and then when a equals 0 and b doesn't equal 0, so that means when the bottom is equal to 0 and the top doesn't equal 0, equation is no solution. So that's more in depth. It doesn't really matter for you guys, I think. Okay. Let's try this problem. Solve the equation a equals -3x minus 5b for x, and keep it in terms of a and b. Right, nice job to the people down there who got it. I think everybody got it right in the end, but I'll explain it. So, um, you have a equals negative 3, sorry, that's a 3, negative 3x minus 5b. And then you want to solve this for x. So first thing I would do would distribute the negative 3 into the x since it's in the parentheses. So just multiply that. So it's negative 3x. Now it's plus 15b. And then that's the equation still kept equal. So then I'd move the 3x to the left-hand side because I don't like negatives. I don't know why, I just don't like negatives. So isolate the 3x to the left-hand side, and then everything else goes on the right-hand side. So this now becomes 3x equals 15b, oops, 15b minus a. And then divide everything by 3 because we're solving for x. So x equals 15b minus a over 3. Right. So this you can simplify this farther, but this is acceptable, but you can also simplify this farther. Like for example, 3 goes into 15b, 5b times, oops, and then minus a over 3. I'm gonna make, okay. So again, just distribute, move all the variables to the left-hand side, constants to the right-hand side, and then divide by whatever the number, divide by 3 in this case, and just make sure you don't make any mistakes. Okay, so let's try this one. It's actually usable in the real world too. So metric system uses degrees Celsius, as you guys know, and the United States uses degree Fahrenheit. And the formula is as follows. Celsius equals 5 times Fahrenheit minus 32 over 9. So the question is solve for F. So solve for degrees Fahrenheit. And it would be in terms of C. Right, nice job to the 3 who got it down there. Um, so I'll walk you guys through it real quick though. Okay, so we're solving for f. So first thing I would do would probably be multiply both sides by 9. So you get 9c equals 5f minus 32. Right. So now we're basically just solving for f. So since if I multiply 5n, I'd probably get a really large number, or I'd get 160, and I don't know if I want to deal with that number, so I'm just going to divide by 5 on both sides. So now we get 9c over 5 equals f minus 32. And then basically I isolate it so that f is on its own side. So now I get f equals 9c over 5 plus 32, which is essentially the same thing as what everybody else has done down here. So again, the steps are multiply both sides by 9, remove parentheses, or in this case, I didn't remove parentheses, but this is an alternate way you could do it. And then isolate variables, divide both sides by 5. Okay, so let's try this problem. Solve for x, a squared plus ax equals 1 minus x. Okay, I'll explain this one since some people seem to not be getting it. Um, I'm not sure if this is correct because it doesn't match what I have, but it might be. We'll figure out. So it says solve for x, and then we have x is on opposite sides. So first off, I'll get the x's together. So I'll just move the right one to the left, and I'll move the a squared over as well. So ax plus x, since I moved it over, it becomes positive, equals 1 minus a squared, right? So now that I have this and I have x's on both sides, I combine like terms. So like right here, this becomes a plus 1 x. Do you guys see what I did there? So like if this was what 3x plus x, I would combine it into 3 plus 1 x, which would equal 4x. That's why I do a plus 1x. So that's not. So that's why I did a plus 1x, and then that equals 1 minus a squared, and then so we get x equals 1 minus a squared over a plus 1, as long as a doesn't equal negative 1. Because if a equals negative 1, then we just divide it by 0, and that doesn't work. So you could have just left it like this, and that would have been fine. I think this person went on to simplify it, which also works as well. So nice. Okay. Okay. Let's try this equation here. Solve the equation ax minus b plus 3x equals 3x plus 5d. Wait, so a quick thing I'd like to mention. I'll let you guys continue solving it, but if you have something that looks like this, for example, 3x plus ax, you can combine the like terms and write this as 3 plus a multiplied by x. So that's like something to think about. And same thing applies if you have like so it's ax plus bx. This equals a plus b multiplied by x, and also ax minus bx. This equals a minus bx. Okay. Okay. Um, Nice job to these two who got it. I think this one this person messed up a little bit on signs, but other than that, they're right as well. That's a nice job to them. Um, you can't, so one of the main things is you can't forget to do parentheses because this makes it so that it's just 5d divided by a instead of the original equation. So I'll explain it. Um, so we have our original one is ax minus b equals 3x plus 5d. First off, I'm just going to move all the x's to the left-hand side and everything else to the right-hand side. So now we get ax. And then this becomes minus 3x. And then move this to that side so it becomes positive b plus 5d. And then here, since they both have x's in front of whatever is in front of them, I can take them out so it becomes x multiplied by a minus 3 equals b plus 5d. I don't know why I wrote that b like that, sorry. Okay, so then we divide both sides by a minus 3. Since it says a does not equal 3, so we're not dividing by 0. So then we get b plus 5d over a minus 3. Which is basically the same thing as what these people got. So nice job. Okay. So I might come back to these other try yourselves later, but we're going to skip ahead real quick. Okay. So the next big thing is solving quadratic equations. Okay. So the following is called a quadratic equation. Ax squared plus bx plus c equals 0. This is going to be the form of almost like basically every quadratic formula you see, where a, b, and c are real numbers or constants, and x is the variable. So before we were only seeing like linear, it's just ax plus b equals c, since there's only one x, but now since like it's only x to the power 1, but now we have x to the power 2, and then once we go up to the square, the solutions become very different. So, for example, let's say originally we were doing things like x equals 11, and then x just equals 11. That's just like a statement. But now if we have x squared equals 11, we have two solutions for x. first solution is the square root of 11, and the other one is the negative square root of 11. Because anything to the squared is always going to be equal to whatever that number is squared, the positive version of it. So like if you said like negative 5 squared, this is always going to equal 25. It's not going to equal negative 25. So it's just when you square something, it automatically becomes positive. So in this case, that makes it so that this has two solutions. One of them is negative and the other one is positive, since once you square it, the sign doesn't matter. Okay. So one way to solve, so like for example, a quadratic equation would be x squared plus 2x plus 1 equals 0. So this would be an example of a quadratic equation. So there are two ways to solve this quadratic equation. The first way is called factoring. So basically, we factor this using FOIL. So this can be turned into x plus 1 squared. And then basically now we have a linear squared, and then that equals 0. And then that's very solvable. The other one, this is like, this factoring doesn't always work because you're not always going to get something that looks really pretty and turns out well. So what always works is what's called the quadratic formula. This is just like a quick run through of how to derive, like how we get the quadratic formula, but I'm just going to run through this real quick. You guys don't have to explicitly know this, but you have to know the formula in the end. So if you have your original one, divide both sides by a, and then complete the square, which is a little bit complicated, and then write the left hand as a perfect square, and then square root it, and then you get your final one. So to solve a quadratic equation of ax squared plus bx plus c equals 0, you have to remember the order of a, b, and c as well. To solve it, we get x. So it's going to have two solutions since it's a quadratic. The two solutions could be the same, and that only have one solution, but it's going to have two solutions. x1, 2 is going to equal, so negative b, so negative the constant of the second term, negative b plus minus. So what the plus minus sign means is it's plus for solution 1 and it's minus for solution 2. So it's like plus minus 1 plus 3. For solution 1, it's going to equal 4. And then for solution 2, it's going to be equal to negative 2. So it just switches off for each of the solutions. So that's how you get two different solutions. So negative b plus minus. So I'd advise you guys to write this down and memorize it. So negative b, if you haven't already, negative b plus minus square root of b squared minus 4ac over 2a. So that's 100% success rate at solving a quadratic equation if it's solvable. Some of them don't have solutions. So again, try and memorize it. If this is the format of your quadratic, like in this one up here, a would equal, like if you can still see this, a would equal 1, b would equal 2, and c would equal 1. So it's just format since it's 1x squared. And then plug it into this equation, this formula, negative b plus minus square root of b squared minus 4ac over 2a. So try memorizing that. Okay, so using that, see if you can solve this equation here. X squared minus 6x equals 40. So what you want to do is first get it to look like this, and then substitute the terms in, and then get your answer. Okay. Nice job to this person and you guys partially. It actually has two solutions, so 4 is one of the solutions, but -10 is the other solution. So I think it'd be helpful if I explained it, so you guys know how the problem works. Okay. So you know how the problem, so how you know, so you know how problems like these work. So, for example, okay. So in our problem is x squared plus 6x equals 40. That's our problem. So to get it to look like something, ax squared plus bx plus c equals 0. To get it like this, we have to get it to equal 0 first. So let's move 40 to that side. So we get x squared plus 6x minus 40 equals 0. So that's step one. So from here, we can see that we can compare, and we see that a is equal to 1, b is going to be equal to 6, and then c is going to be equal to -40. Right? So a is equal to 1, b is equal to 6, and then c is equal to -40. And then we plug it into our equation right up here. So it's x12 is equal to negative b, so that's -6, plus minus, we won't deal with that right now, we'll deal with it later. It's the square root of b squared, which is 36, minus 4 times a, which is 1, and then b, which is -40, and then we'll simplify that later, all over 2a. And then a is equal to 1, so it's just 2. And now we just have to simplify this to whatever number we get, so let's do that right now. So this is equal to -6. Let's deal with the square root before we do anything, to the square root of. So what we now have is 36, and then we have -4. We have -4 times -40. So then that's -160. Sorry, -4 times -40, right? Oh, it might be -10. Right, yeah, it's -10. Oh, sorry. So it's -4 times -40, which comes up to positive 160. Over 2, right? So all I did there was multiply this out to be 160, and then took the square root of that. Okay, so now we have, continue with this, -6 plus minus, still there, the square root of 196 over 2. So what I did was I added whatever's in the denominator together and took the square root of that. So if we were to take the square root of 196, we get 14, I believe. Yeah, 14. So -6 plus minus 14 over 2. So finally, we get this right here, -6 plus minus 14 over 2. Let me just clear that. -6 plus minus 14 over 2. So the first one, so that's x1, 2 is equal to this. So the first one, x1, is going to be equal to -6 plus 14 over 2. And then x2 is going to be equal to -6 minus 14 over 2. Once we solve this, we get 4. Once we solve this, we get 10, -10. So that's how you use the quadratic equation to solve a quadratic formula. It seems really complicated, but once you get like the steps down and once you've done enough problems, it just comes like naturally. You know what the formula is, what to plug into each formula, and it goes by really quickly. Okay, let's see. Okay. Okay. So the next, let's try example number 2. If you guys can't see it, I will write it up here for you. So 5x squared equals 10x minus 4. So try that problem and see if you guys can get this. So solve 5x squared equals 10x minus 4 using the quadratic formula. And I'll scroll back up so you guys can see this quadratic formula. Oops. This is the quadratic formula again. So I'll give you guys a little bit of time to do this. Okay, if you haven't got it, that's okay. I'm gonna just start working on it silently on the side over here.
Joseph!
Okay, I think I'm just gonna explain it so for you guys. Nice job to this person who got it though. So as you can see, I've already started to solve this right here. We see it's what I did was move everything to the left-hand side so it could be equal to 0, and then I could start solving the quadratic. And then right here, I see that a equals 5, b equals -10, and then c equals 4. And then I plugged in the equation -b plus minus the square root of b squared minus 4ac over 2a. Right. Nice job to this person. You can simplify the square root of 20 into 2 on the square root of 5 though, but nice job. So then I plug it into this equation here, and then I get this. First plug in -b, -10 is 10, plus minus the square root of b squared, which is 100, minus 4ac, which is 4 times 5 times 4, which is, that's 80 actually. Yeah, that's 80, okay. So it's 100 minus 80, which is 20. And then we end up with this, and then we can further simplify this into 1 plus minus, and then this turns into 2 on the root 5 over 10, which further can be simplified into 1 plus minus square root of 5 over 5. Alright, so just remember the steps are get it to look something like this, see what A, B, and C are, and then plug into the formula, which you should try to memorize. So it's always going to be equal to 0, and then in front of x squared there's a term, in front of x there's a term, and then in front of C is going to be a constant. Okay, actually, I think that's where we're going to end class today. Notes will be posted on the forum. We're going to have class same time next week. Thanks for coming, guys. Have a good week. Bye.